it was on, I think, on Wednesday. So what had we completed in that session? Any one of you just quickly recollect that?
Yes, ma'am.
Yes. What had we seen
Final
in last lecture? Mhm.
FSA.
Okay, FSA. What else?
We have done some examples on it.
Very good. Okay, we had started with FSA and we had done few examples on that. Yes, so in today's session also, we will continue with our FSA, but we will start a new topic in that. That's called it's called as an wait, DFA, that's Deterministic Finite Automaton. And we have non-DFA, non-deterministic finite automata, that is NFA. Just give me 2 minutes, then I'll share my screen. Okay, so yes, in last lecture we had seen some topic that is called as how do we denote a particular finite state automaton, right? How do we denote that? So we will see that in detail. So basically, consider your finite state automata. Okay, your finite state automaton. Okay, so it's basically what is this? It is shown in the form of M. It is a five tuple. It is a it is a five tuple. Now you must be aware of the tuples. What are this? These are the values of a particular table or some elements present in a table. So a finite state automaton M is a five tuple and it is shown as M is equal to K sigma delta Q naught
Not
and F.
F.
Very good. So it is stated that, and basically what are the uses of finite state automaton? It is called as a language acceptor, or it may be called as a recognizer. Why is it called a acceptor, guys? Because, for example, if I am passing on a string triple A B B, any string, okay, this is just an example for your understanding. If I am passing on a string on a particular finite state machine or finite state automaton, the output, I'll have to check. I will see the traversal of this particular string in the particular states, and I will see that whether that is accepted or not. So it should be either accepted or recognized by the FSA. And when can we say that it is accepted? When it reaches the final state, okay? When our final value, see here, suppose I begin with A, then I'll move on to my next value A, then A. When I finish traversing all the values present in the string, my last value is B, right? So my last value of string, or at last I should reach my final state. Only then I can say that the particular string is accepted by the finite state automaton. Okay, now the formal definition of finite state automaton is that it is denoted by M, it is given by M, right? So a finite state automaton M is a five tuple and M is equal to K, sigma, delta, Q naught and F, where K is what is K? K is actually finite set of states. Getting it? K is finite set of states, whereas sigma is the finite set of input
Input symbol.
symbols. Very good. Input symbols, right? Now, what do you
Yes.
mean by states? What are states? States are represented by the circle. Okay, by the circle. Initial state is represented by an arrow which is pointing towards itself. That's why it's called as an initial state. Similarly, final state is shown by double circle like this. Okay, these are the initial state, and both are related, and both are we are showing the transitions in between them. If we have some values like 0, 1, etc., etc. So basically, K is the finite set of states, and sigma is the input symbols. Here, the input symbols can be 0, 1. So sigma is the input symbol. Similarly, our delta, what is delta? Delta is actually called as a transition function, or it is also called as a mapping from okay, delta is called as a transition function. So it means this, it is represented by these arrows. Either it can be clockwise or it can be anti-clockwise, towards right or towards left, etc. That is called as a particular transition. So delta is a transition function, or it is also called as a mapping from, it is also called as a mapping from
K
K
multiplied by sigma into
multiplied
K.
by sigma into
Into
K.
into K.
That is given by K multiplied by sigma into K. This is how it is written. So this is how we compute the value of delta or transition. Then we have Q naught. Q naught is our, what is Q naught?
initial state.
Very good. Q naught is our initial state, and similarly my F is
Final state.
final state. So you have to remember this. What all values M is having, how it is a 5 tuple. Why? Because it consists of this: K, sigma, delta, Q naught, and F. Okay, so this much is clear. Now we will see something called as, we had seen this state diagram. We had also seen state table, etc. Yeah. Now let us take one example over here. Let's have an example. And one more thing here to remember is that delta is shown by a table. Delta means we have to show that in terms of a table, a state table. Here, where you can have various inputs. For example, my two inputs are A, B, and your various states, Q naught, Q1, Q2, dead state, etc. Okay, and then I have to show the transition in between them. Okay, now our next topic here, we will just quickly finish with few other theories which are remaining. Our next topic is, yeah, you should remember that D is what? D is the dead state. What it means? It is not a final state. It is a dead state. It won't give you the exact, it is not the final state. Now, for example, consider sigma is equal to A comma B, right? Sigma is equal to A comma B. And suppose I'm drawing the state diagram as this double circle. This means what? It is the final state. Okay. But here is a new concept here, that why not this final state can also be the initial state. Okay. Now consider an example like this. We have two transitions which we are showing here, A and B, right? Now what is this basically? It is set of, this is nothing but this is sigma star, which indicates that any strings, it indicates that any strings of A's and B's, of A's and B's are accepted by the machine, are accepted by the machine. So you have to remember that if the initial state, okay, if initial state is the final state, as you can see in this state diagram, the initial state itself is the final state. So if initial state is the final state, then the empty string will be accepted. It says that then the empty string will be accepted. Okay, empty string will be accepted. That is what it is saying. And it is shown by sigma star. This is nothing but this is sigma star, which is any set of strings of A's and B's. Means it can be any set. Okay, any occurrences of A's and B's. So any sets of A's and B's are accepted by the machine here, and it is shown by sigma star. And what was the formal definition of sigma star? It was set of all strings, yeah, present over a language. Okay, and one more note you have to always remember is that if your initial state is equal to the final state, or it means if the initial state, how the initial state is represented, whenever you have a circle or whenever you have a state and it is beginning with an arrow, one arrow is always pointing towards the state that is called as a initial state. Initial state. Okay, so if your initial state itself is the final state, then what happens? Then the empty string will be accepted. And what is my empty string? It is epsilon. Empty string is shown by, or it is represented by epsilon. So it says that whenever, if the initial state is the final state, then the empty string will be accepted. Means your epsilon will be accepted here. Okay. So this was your first concept which you have to remember, sigma star, and it is shown in this way. Set of all A's and B's will be accepted. Now our next one is, now suppose I'll give you an example, okay? You have to tell me whether that is accepted by our finite state automaton or not. Okay, now let's take an example. Suppose I have a state diagram like this. Okay, I'm drawing the state diagram. Suppose I have my state diagram like this. So don't get confused that how a final state can be a start state. Yes, it is possible. The definition here states that the initial state can also be the final state, and whenever the initial state is the final state, then the empty set is also, or empty string is also accepted. Okay, now let us see this, draw this diagram. I'm having three states here, Q naught, Q1, and D. Q naught is my start state and all, sorry, initial state, and it is also my final state. I have another state Q1 and a state D. D is my dead state. Okay, dead state means it won't allow, it won't reach the final state, so that whenever the values or the inputs does not reach the final state, or it goes to some other state, that some other state is called as a dead state. So I'll show the transitions in between them. Okay, you can also draw it along with me. Okay, suppose this is the state diagram I'm showing to you, and you are asked, the question is, okay, the question will be, check whether check whether by the FSA. How will you do
Ma'am, your
that?
voice is breaking.
Accept. Am I audible now?
No, ma'am.
I'm
I think
still
there is
breaking.
some network issue.
Yes, ma'am.
Okay, now?
Yes, ma'am. Now it's clear.
Okay, okay. Okay, so this state diagram is given to you. And what's my initial state? My initial state is accepted. Okay. So the question given to you is check whether the string this AB is accepted by the FSA. You have to check that. Okay. Now check. Is it accepted? Just check the traversal. Okay. My first string is A, right? So for that, what you'll have to do, you'll have to draw a state table, isn't it? You'll require
Yes,
a
ma'am.
state table for that. And how a state table is given? First step is you write the input values, right? Then you write the state sequence, input value, then you write the state sequence, and then you write the output. This is how it goes. Okay. Now, what's your input here? How will you write it?
First is
Input
A,
is
right?
our string, no? A, B, A, B. Input is our string. A, B, A, B, and again, you'll have to write A, B, right? That is our this present in my initial I'm present in my initial state. So I'm Q naught. Before proceeding, I'm always in my initial state. Now you check. Okay, Q naught for A. Whenever what is my input? Okay,
Q1.
Q naught
Q1 will
having
be
the input as 1, but it has to go it has to go to Q1. So I'm reaching at Q1, and what will be my output in that case? Am I
Q1.
getting an input over here? Yes,
Ma'am, your
Q1
voice
is
is not clear.
your next state.
Ma'am, your voice is breaking up.
Just a minute. Okay, I think there is some network issue. Okay, now I have to show the output here? Yes or
No,
no?
ma'am.
No, because I just have to check. I just have to check whether the string is accepted or not. And when can we say that the string is accepted? When we are present in the final state by the time we finish traversing that string, we should be present in the final state.
Yes, ma'am.
Now I have reached Q1 with the input A. Now when I check for for the input B, Q1 and I'm going to Q naught again. So now I'm
Yes.
changing my position. I reached Q naught. Then again, I'll have to check in Q naught. Whenever I'm getting the input as A, again, I have to go to Q1. So
Ma'am,
here
it is
I will write Q1. Is it, yeah, very, it is accepting. Have you solved it?
Yes,
Yes.
ma'am.
Okay. Then Q1 for B again, it will give me Q naught. Then what will it give me again? Q1, right? Then Q1 for B. Yes, very good. So we are reaching our final state. This is our final state Q naught. At the end of this string, this is the end of that particular string, right? So the string is finished now. We don't have any values pending. Our last value was B, right? So it means that at the end of a particular string, if we are present in the final state, only then we can say that the string is accepted. So in our case, the string AB is accepted by, yes, is accepted by FSA, that is finite state automaton. This is how you have to prove. Okay. Now we will see one more example. Should I erase this? I'm just erasing. Okay. You just tell
Yes,
me
ma'am.
if you're noting down.
Done, ma'am.
Okay. Okay. Now next is what? Okay. We had done with this sigma star, right? Sigma star means what? It contains all the values of, or all the sets or strings of A's and B's are accepted. Then can we say that a particular machine or a particular value is accepted, right? Now similarly, we can have sigma plus. Okay. This sigma plus is what here it means that any state of A's and B's, any state of A's and B's are accepted, but not epsilon. Okay. What's the difference between sigma star and sigma plus? In sigma star, epsilon is accepted, but in sigma plus, any combinations or any states of A's and B's will be accepted, but epsilon is not accepted. Yes, and one more point to remember is if your initial state is the final state, then empty string will be accepted. These are the few points which you have to remember. Empty string
That's the
is,
opposite, ma'am.
yes, is accepted. So sigma plus is opposite of that. Here empty string is not accepted. Very good. Now after that, there is a concept which is called as DFA. Okay, DFA. Now, if I give you a question, okay, before that, let us take an example, very good example. Okay, so in this example, so take down a question. The question is, consider the string, okay, consider the string 011 over the binary alphabet, over the binary alphabet, okay, all the prefix, you have to check what? All the prefix, suffix, and substrings of this string, okay? All the prefix, suffix, and substring the are what are prefix, suffix, and substring of the string are. Okay, so first we will begin with prefix, okay? The solution here goes in this way. In prefix, check the value. String given to you is 0, 1. My prefix values will be, it contains an empty string. It will be epsilon, it will be 0, then 0, 1, then 0, 1, 1. This is my prefix. Similarly, my suffix will be epsilon. It starts from the last, okay? Suffix. Then you will have 1, then you will have what? You will have 1, 1. Then you will have the complete string 0, 1, 1.
110.
Okay.
01.
What happened?
No, ma'am. No, ma'am.
Okay, 011, because the string is 011. You might have a question here, why can't we write it as 110, right? So that becomes totally opposite of that. We have to show that complete string which is given to us. That's why it is 011. Now again, if I want to write substring, what will be my substrings over here? Substrings here will be epsilon, it will be 0, it will be 1, then 0, 1, yes, 1, 1, and 0, 1, 1. Okay, epsilon 0, 1, then you have 0, 1, 1, 1, and your complete string 0, 1, 1. These are the values of prefix, suffix, and substrings of the string which is given to you. Now you have to compute the power. Okay, how will you compute that? Yes, power of a given string. Okay, now to compute the power of a given string, okay, power of string. For example, here x is equal to 0, 1, 1. It is given. This is our string, right? 0, 1, 1. What will be my value of x raised to 2? X square will be 0, 1, 1, 0, 1, 1. Then my x cube will be again 3 times that particular value, right? 0, 1, 1, 0, 1, 1, and again 0, 1, 1. Getting? So this is how you compute the power of strings. X square, x cube. In this way, you have to show that. Okay, now let's start with a new concept which is called as deterministic finite automata. So before we proceed to that, you'll have to understand that what are the various types of finite automatas and what are the concepts behind that. Okay. So just finish. If- Are you writing this? If you finish, we can proceed.
Finished, ma'am.
Okay, okay. Okay, next is as we have started with finite state automaton. This finite automata is further classified into various types. Finite automata, finite automata is further categorized or classified as this way. Okay, we have finite automata with output, and finite automata without output. Now, with output, there are two types. That is called as something called as Moore machine, and another one is called as milli machine. Those are the types of finite automata with output. Now, finite automata without output are DFA and one more, you have NFA and you have epsilon NFA, that is minimized NFA. Okay, you have to remember this picture and this classification. The finite automata is classified into two types: finite automata with output and without output. If it is with output, it is further categorized into Moore machine and Mealy machine. Okay, these are the types of FA with output. Now the types of FA, finite automata without output, are DFA, NFA, and epsilon NFA. DFA stands for deterministic finite automata. NFA stands for non-deterministic finite automata, and epsilon NFA is the minimized version of non-deterministic finite automata. These are the types of finite automata. Okay, so if a question comes, what are the various types of finite automata? So you should be aware that finite automata is classified into finite automata with output and finite automata without output. The examples or the types of with output are FA with output are Moore machine and Milli machine. Similarly, the types of FA without output are DFA, NFA, and epsilon NFA. Okay. So write down. Okay. Now the definition of DFA goes in this way. Okay. DFA is basically DFA. DFA, it stands for what? It stands for deterministic. Okay. It stands for deterministic finite automata. Deterministic finite automata. It is either called as automaton or automata. In some books, it's referred to as automaton, whereas somewhere it is referred as automata. Okay, but both of them are the same. So DFA stands for it stands for deterministic finite automata. Okay, and it is the simplest. It is the simplest model of computation. Getting? It is the simplest model of computation. Model of computation. And it has a very limited memory. These are the few information about DFA. It has limited memory. Okay, now let us take one example over here. Now I will draw one state diagram here. In that, we will show how that is represented in the form of M. And what is my M? M is your finite automaton, right? And M is it is made up of 5 tuples, right? Yes, M is made up of 5 tuples. So let me just quickly give you one example. Okay, let us take one example here. For just draw the state diagram, which I'm drawing now. I have a state A, I have state B. I have 4 states here, A, B, C, and D. Right? D is my final state. And A is which is my start state? A. Here A is my suppose. Okay, this is an example. This is just an example. Suppose I have 4 states here, A, B, C, D. A is my initial state and D is my final state. My transitions are shown in this way. Okay, transitions are shown in this way. Like this. You can just draw it. 1 and then again I have a 1 over here. Then I have 0 and then I have 0 again. Okay, now I'm done. Okay, I'm done with this state diagram. I'll write it properly. This 1 over here, I'll just shift it. Okay, this is the state diagram which is given to me. And the definition of finite automaton is it is a 5 tuple value and it is given by M. So similarly, FA is nothing. DFA is what? DFA is also a finite automata, right? This is an example of DFA, what we are doing, right? DFA is also a deterministic finite automaton. So DFA, we can say that DFA can be defined. Okay, DFA can be defined using phi tuple. Is this clear? Is this line clear? Why it is called as phi tuple? Because FA is a phi tuple. Okay. And since FA is a phi tuple, its types are what? DF is one of the type of FA, right? That's why DFA is also a phi tuple value. Okay, so DFA can be defined using 5 tuple. What are the 5 tuples here? You have Q. Now you tell me, okay? Q. Then you have Q. Then we have sigma. Then what else?
K, delta,
Yes, K is
delta,
nothing. Yes, yes.
F.
So is it Q or K? Just check out your finite automaton. You are having the values in terms of Q or K?
Q,
Q. See, for your finite automaton, you are having 5 tuple as M is equal to K, sigma, delta, Q naught, and F. Okay, this was for finite automaton. Now, when we are speaking about DFA, deterministic finite automaton, it is given as M is equal to, this Q is nothing but it is K. Okay, so in standard notation, it is given as Q, sigma, delta, Q naught, and F. Okay, why it is given in that way? Because K is what? K is a finite set of states, right? Similarly, here Q is also a finite set of states, but there is a slight I mean distinction between the FA and DFA. There has to be something, right? So for that, the notation of K is given as Q in terms of DFA. So everything remains same, only the K value is replaced by Q here, right? So here the meaning is the same. Meaning is the same. Okay, set of states. Similarly, this is also set of states. But to understand, you should understand that whether it's a FA or DFA, right? When I have K, it means that that is a finite automaton. But if it is K over here, then I can say that it is a DFA, deterministic finite automaton. Only that is the difference. Nothing else. But the meaning is same, that it is the finite set of states. Okay, now represent that in this way. Now what we will do is, okay, this example we had taken. Okay, what's remaining now? Q, sigma, delta, Q naught, and F. These are my 5 values. It is, since it is a phi tuple, so these are my 5 values present over here. Now what will I do is, I will just take a quick example so that you can understand it, okay, in a better way. Okay, now just draw one state diagram. This Draw this state diagram. This is a question. Okay, question number 1. This is a state diagram. Draw the state diagram. Okay, here you have to show the values of DFA, right? DFA is a 5 tuple. That's why we are having this many values. Now you write the values over here. Q is equal to, what is Q? Q means what? Set of finite states. And how many states I'm having here? 4 states, A, B, C, D, right?
Yes, ma'am.
So I will write that A, comma, B, comma, C, and comma D. These are my various states. Then I'll write sigma. Sigma means what? Your input
Finite set of
symbols,
all
isn't it?
input. Yes, ma'am.
Input symbols, sigma. Sigma is the input symbols. So input is either in the form of 0 or it's in the form of 1. These are my inputs, okay? Inputs. Get it?
Yes, ma'am.
So sigma is equal to 0, comma 1. My Q naught is the initial state. And what is my initial state? It is A. F is my final state. And my final state is D, right? It is actually final set of states. Okay, it should be a final set of states. That's why it is shown in the form of a set like this. And now we don't know delta. What is delta? Delta means it is actually the transition function. We don't know the value of delta, but we have to compute the value of delta. But and how to compute the value of delta over here?
First we'll
It is done by
need the Cartesian product of K and sigma, right?
yes, it is the Cartesian product of K and sigma. So for that, I'll have to create a table to compute the value of delta. I'll have to, okay, I'll show it here. We don't know the value of delta, and for that, I have to make a table. Okay. For example, check this. I'm just making a table over here with the number of inputs and the number of states. Here, I will represent my states. Okay, this is for representation of states, and here I will show my inputs. What are my inputs? My inputs are 0 or it can be 1. My inputs are 0, 1, right? See, check everywhere. It is either 0 or it is 1. Okay, last value we have not written. Just give me a few seconds to just write it down. It is 1. Okay, suppose this is 1. And my states are 4 states I'm having A, B, C, D. Now check in the state diagram and tell me the values over here. What can be the values over here? Just tell me.
And we can just write 0A, 0, 1, 0, comma A, 0, comma. I'm sorry, A comma 0, A comma 1, B comma 0, A comma 1. Will those be
Yes, you
the...
can. Yes, you can write it in that way also. But if I want to write the values over here uh, in the table, it can be in the form of the states A, B, C, D. Yeah.
Right.
So check out for A0. When is A giving? When is A having the input as 0? Over here, right? When it
Yes,
goes
ma'am.
to C. When it goes to C, I'm having the input as 0. So I will write C here. Similarly, check for A1. A1, yes. When it goes to B, I'm having the input as 1, right?
Yes,
From
ma'am.
A to B. So I'll write B here. Then again, B to 0. B0, I'm having the input as 0, but when B goes to D, right? So I'll write D here. Similarly, you complete everything, then you get all the values as like this, D, and then you have BC. This is what you are showing the table, transition table, and this is equal to your delta. This complete table is your transition function delta. Transition function delta. And by the definition we have delta is what? Delta is nothing but k cross or k plus. It is k cross sigma
K cross sigma 2
ah,
into K.
into k. This is what is, yeah, very good. So this is what it is giving me. What is my k? K is my finite set of states, means this, okay, A, B, C, D, into sigma. Sigma is my input symbols, that is 0, 1. K cross sigma, it is giving me k, right? K itself. And what is k? K is the states, right? A, B, C, D. That's what it is giving me, right? A0 we got C, A1 we got B, and so on. So it's hence it is proved, okay? And this is our final table, or this is our delta. Delta is this table. Okay, now we will solve one example, and then I'll give you one example. You have to solve it, okay? We'll just take one last example and then we'll stop for today. Okay, so the question is, construct a DFA. I think it's better to write it down. The question here is, construct a DFA that accepts. Okay, construct a DFA that accepts. Suppose this is our second question. My question is, construct a DFA that accepts, we will solve this last example, that accepts states of all strings, that accepts states of all strings over 0, comma 1 of length 2, of length 2, right? Okay, I have to find a solution for this. What will be my solution? This is a question which is given to you. Construct a DFA that accepts states of all strings over 0, 1 of length 2. And we all know that M is equal to, if it is DFA, it is Q, comma, sigma, comma, delta, Q naught, and F. This is how M is represented. Okay. Now, what are my values of sigma? Sigma can
0,
be,
1.
yes, sigma is set of input na, so it is 0, 1. Why? Because we already have it 0, 1, right? Next one is we have what do we have from this question? Okay, just look out in this way. In the question, from the question we can get two inputs 0, 1. That is my sigma. I have length 2. Length of my input should be 2. So that is L. Length is equal to what? It can be either what? Length should be 2. It means it can be 0, 0. It
0,
can be
1.
0, 1.
1, 0, 1.
1 0 1
1.
1.
Very good. 1, 0, and 1, 1. This is how the length. Okay. Why? Because I'm having the length as 2. If the length was 1, it could be 0 or 1. Yeah,
1.
like that.
Yes.
But now let us have a look into this. Okay. Now comes important part, state diagram. Once I have finished out finding the values from the question, I can compute the state diagram. So how will be my state diagram? We'll directly draw it. Okay. Okay, what will be my state diagram? So should I get 4 states here? A, B, C, D. Let's see how it goes. Okay. Initially, I begin with my start state, or my initial state is A. For example, I'm having my initial state as A. Okay. Now A can have any values. Okay. A can have either 0 or it can have 1. At start we don't have the transitions. Okay, we don't have the transition values of that. We are just aware that it is having either 0 or it is having 1. So what we will do here, we will directly show it. We will pass on 0, comma 1 to a new state, next state, that is B. Okay, because we are not sure about the transitions, that's why we are giving the input as either it could be 0 or it could be 1, and we are passing that to B. Okay, similarly for B also, from here also we do not have anything. Why we are proceeding further? Because as the definition is that we are more interested in the length 2. But here, if I'm transmitting either 0 or 1, it means what? This is actually what? This is actually A. This is actually A1, right? This is actually A0, or it can be 1, like this, right? Either it can be this or it can be this, right? We are not sure whether which value is going to the next state, 0 or 1, but we know that 0 and 1 both should be there, or both can be there. So this is nothing but this is represented by this. Okay, but here when you check the length of 0, what is the length of 0 here? My length is 1. Similarly, when I am sending 1 to B, when my input is 1, the length is 1. That's why we cannot stop over there. So B cannot be my final state. B cannot be my final state because I'm not reaching my goal, because the length is still 1 year. So I will again transfer. I will again send that 0 or 1 to my next state, that is C. Now will C become my final state now, guys?
Yes, ma'am.
This is actually A, B, and C. It is giving me either 0, 0, or it will give me A, B, or C. It is giving me 1, 1, or it can be 0, 1, or 1, 0, etc., etc. So this is accepted, and this will be my final state C, right? This is how you need to draw a state diagram from the given question. Okay. Now this is my final state C, right? Now we should not stop here, right? After this also you should keep on checking whether you are getting the same length value or the value of the length is increasing. So I'm interested in that also. Okay, so guys, just don't stop over your final state. Show one more state. Take one more state here, A, B, C, D, right? Take one more state here, D, and the value, it can be 0 or it can be 1. Now, what?
Your voice is breaking again, ma'am.
Now see, still I have to check कि इससे ज्यादा भी हमें वैल्यू मिल रहा है या नहीं मिल रहा है, right? Whether we are getting it or we are not getting it. So we have to check. Just for checking, I am introducing a new state D here. And when I'm transmitting the values of 0 or 1 from C to D, I have observed that for D, the length is becoming as 3, right? And
Yes,
that
ma'am.
is not accepted. Length is 3, that is not accepted. Then from D also I want to check twice, guys. Okay, so here what we will do is we have to check twice. We have to be sure, right? So length is 3, so it's not accepted. So if I give one more 0 1 to D itself, then again the length becomes 4, right? It is not accepted. So D becomes our dead state. So always show dead state also, after computing that. So this is my dead state, right? D is my dead state, or it is also called as a trap set. Sorry, trap state it is called. Okay, it's better to call dead state. Okay, so D is the dead state. So this is how we draw a state diagram from a given question. So we will stop here. This is our example. We will take more examples in the next lecture. Okay, okay, just tell me, is this clear this much?
Yes, ma'am.
Ma'am,
Oh, ma'am.
Oh, yes,
um,
yes, yes,
if we okay, so if
yes.
no, I understood. Oh, and I understood. Okay, never mind.
Uh-huh. Okay. Yeah, you can just go through this example, take a picture, and then try to solve it by your own. Okay. And if you are getting stuck, let me know in the next lecture so that I can clear the doubts. Okay.
Ma'am, explain once more in the next lecture, ma'am.
Okay. Okay. Sure. I'll explain this once more. Okay.
Yes, ma'am.
So let me take your attendance now. Okay. Let us